Good afternoon. I hope you guys are doing well. It is 3:30 in the p.m. I started a little bit late because I was watching anime, and I decided I'd rather finish the series and be done with it than start my shit on time and have like one episode left. So we did that instead. That said, so today we will be dealing with concepts. Now, I don't know what concepts means. But I do know if we look at our chapter things, we had like function overloading and lambda functions and function templates, all that good shit. And then we have now C++20 concepts crash course. Now, I don't know exactly what that means. I do know that, holy shit. I do know that it is about an hour long, an hour and 10 minutes by the looks of it. So I don't know how long the stream is going to be. Because last time we kind of got distracted and what should have been about like an hour turned into 3 hours, 3.5 hours. So we're gonna take this as it comes. I'm not 100% sure how this is gonna be because concepts doesn't sound like the kind of thing that there's a whole lot of practical stuff for. But you know, I have a folder. I have a session of VS Code ready. You know, obviously. So yeah, let's get into it. I'm excited to see where this goes, because this is chapter 16. After this, we do classes, which classes is a 3-hour session. So that one I'm probably gonna break up into multiple days. And then after that is inheritance, which is another like 3 hours, 3.5 hours. So that's probably also going to be broken up. And then polymorphism is like 5 hours of stuff So that's probably going to be broken up over the course of a week or at least 3 days, I'd imagine. So we're coming up on the end. We're coming up on the end. We're looking at we're long since over the hump, and we're on the downhill towards the end of uh this particular video. You know, I don't want to say the end of the journey or something, because I'd like to do something with this. I'd hate to learn these skills for no reason. So, anyways, we're gonna go ahead and go over to our coding scene that I created, and boom. So the video is there. This one is still on 35 for some reason. We need to make it project 36. There we go. All right. So we're going to start with concepts. Daniel Gakwaya, take it away.
I would like to welcome you in this new chapter where we're going to be learning about concepts. Concepts are a mechanism we can use to set up constraints or restrictions on the template parameters in our function templates. For example, we can use this technique to say that we want our function to be only called with integers, and if you call it with something that isn't an integer, it's going to give you a compiler error. One thing I should emphasize is that concepts are one of the big 4 features in C++ 20, so we're going to be learning about this in this chapter. We have just said that we use them to place constraints on our template parameters, but we saw that we could do something like that in the last chapter where we could use type traits and static asserts. For example, if you look at the function here, it's going to print a number, but we have a requirement for this number to be an integral type through the static assert that we have here. We're going to see that
so static asserts are a new thing.
Really similar with concepts.
We have not touched those.
But it's going to be much cleaner in that the logic to enforce our constraints is not going to be in the function body. It's going to be somewhat in the function declaration in the constraints that we put on the template parameter here. We're going to see specific syntaxes of how you can do this starting in the next lecture. There are 2 sides to concepts in C++. There are standard built-in concepts that come with the C++ programming language. But if for some reason these happen not to be enough, you can build your own, and we're going to see how we can do that later in this chapter. Here are a few examples of concepts you can use in your C++ program. You can use the integral concepts to enforce that your parameters be integrals. You can use the floating point concept to enforce that your template parameters be of floating point type. You can do all kinds of crazy things. Okay, concepts are really cool, and they are going to make your function templates much safer to work with. We are going to stop here in this lecture and show you how you can use concepts starting in the next lecture.
So custom concepts sounds like integral, right? Makes sense. Fucking some of these things kind of make sense. It says what it does on the tin, same as specifies that a type is the same as another type. Derived from. I don't really know how this stuff works, like how it's used. But what the little thing here that tells us what it does, it seems like it's supposed to be like, hey, it tells you what it does in the name. I think that the built-in stuff my understanding of the built-in stuff is that it's things like that we don't have to create. Like obviously, it's like stuff we don't have to create ourselves, but like I'd imagine something like this is probably like int is probably that seems to me like the kind of thing that's like a built-in concept. But I guess we'll continue and see if that holds, if that makes any sense, if that's it. Maybe my opinion has changed or I learned something new.
Go ahead and finish up here and meet me there. In this lecture, we're going to learn about concepts. Again, concepts are a mechanism we have in place in C++ 20 to place constraints on our function templates. For example, we can use concepts to specify that we want our function template to only be called with integers or doubles or strings or whatever, and when somebody violates our concept, they're going to get a compiler error. In this lecture, I am going to show you how you can set up your concept and different syntaxes you can use and how we can understand them. But before we do that, please note that there are two sides to concepts. There are concepts that are standard and built into the C++ standard library. And those are
Right.
ready to use, and these are what we're going to be using in this lecture. But know that you can also build your own concepts and use them to do whatever it is you want to do. Here are a few examples of built-in concepts we can use from the C++ standard library. We have, for example, a concept we can use to enforce that people call our functions only with integral types. If they violate this, they're going to get a compiler error. We can
Okay.
also enforce for our template parameters to be floating point. We can do all kinds of crazy things. Okay, now that you know this, let's see how we can set up a concept on our function templates. And this is the first syntax we're going to look at.
Okay.
All you really have to do is to put in your template declaration like we have been doing all along. You also have to add in the requires keyword here. After the requires keyword, you're going to specify your concept and specify your template parameter in angle brackets here. When you have this thing in front of your function template like we have here, the function template can only work right if the concept in here is satisfied. And this concept in this case is going to be satisfied if somebody tries to call this function template only with integral types. If they violate that, again, they are going to get a compiler error. Okay, once we have this concept set up, we can look at a piece of code that tries to use it and try to guess what is going to happen.
Okay.
Here is a piece of code we would set up in the main function and
All right, let's see if I can read this. I want to try and parse this. I don't know if I understand this properly. I want to make a guess as to what's supposed to happen here, and then we'll listen to the video and see what's going on. So, here we create a character, interesting, that is called A_0 with a value of 10. And then here is a character with a A_0 with a value of 20. Auto result underscore A is add A0 and A1. So here we're using a function to add these values together. And then result A, static cast. I don't know what static cast is.
try to call
Oh,
our function template.
I don't know. Hold on. I'm gonna try. I'm gonna see if I can. Maybe CPP reference has something for me. CPP reference static cast. Static cast conversion. Explanation. Only the following conversions can be done with static cast, except when such conversions would cast away costness or volatility. I don't know what that is. If expression is an L value of type CV1 base and target type is a reference to CV2 derived, the result refers to the object of type derived enclosing expression if all following conditions are satisfied. This is like reading Greek to me so far. Like I can kind of understand it, but I don't know what some of these terms are. Like I know like I think I know what like L value and then like but then like CV1 base, CV2 derived. So derived is a complete class type. Base is of a base class of derived. CV1 is not a greater CV qualification than CV2. If any of the following conditions is satisfied, the program is ill-formed. Base is a virtual base class of derived. Base is a base class of a virtual base class of derived. No valid standard conversion pointer to derived to pointer to base exist. So what it seems like, based on that short reading, this very simple thing, is it seems like we're trying to convert whatever result A is into an integer, is my guess, because these are both characters. So I don't know exactly. I think that one of them would be I want to say one of them is a capital A, B, C, D, E, F, G, H, I, J. I want to say it's a capital J, and the next one is K, L, M, N, O, P, Q, R, S, T. A capital T by default, but then if we convert them, then it actually turns into this. I have no idea if that's actually correct. This is a total shot in the dark by me because I don't know what that thing is. Here we create an integer b underscore 0, b underscore 1 with values of 11 and 5 respectively. So here we have auto result b is adding b0 and b1. Oh, I didn't finish this, I guess. So this part, so this one should be a capital, so this one, when you add them together, should be 30. So the result, like if you're adding the characters together, I guess. I assume that it's trying to do the conversion after the fact. It's weird. I have no idea what's going on in the top here. My guess is that the intent is to try and try to get a 30 out of it. And then this one here, it seems pretty simple. We just add 2 together, and it's like we're adding 11 and 5. So this one should just say 16. Integral concept not satisfied. I assume this one doesn't work because it's a double and requires too much memory. And so this one says, where it says error std integral type not satisfied, it can't do a conversion. Like here we have the static cast trying to convert to integer. So even though all we're doing is adding these, and theoretically 13 could also be an integer because these are both doubles, and we're using auto, it'll try to create create a double result because we're trying to do that. But because I think the template we had before doesn't this can't satisfy it. That's my guess. That's my guess. Let's see if I'm even close to right. And also for now, we're gonna look at that. We're gonna make this the whole thing for now, because I don't know how much of this we're gonna get to do in practical. I'm gonna move this up just a tad. There we go. Perfect. All right.
We have two variables of car type. We know that car is an integral type. So if we issue a call like this call is going to work. The template instance is going to be generated, and it's going to be called and give us the results that we can print here. This is right. On the second piece of code here, we have two variables of type int. We're going to call our function template with int. And this is also an integral type. Int is an integral
What's
type.
2.0
so
plus 1.0?
Generate our function
3.0
instance, and we're going to call it and get the results that we print here. And if we try to call our function template with double types, the concept is not going to be satisfied, and we're going to get some kind of error, and our function template instance is not going to be generated. This is really how you can use concepts to force some rules on users of your function templates, if I can say it like that. We have been able to do something like this using type traits and static asserts in the last chapter, but
static asserts, we haven't done anything with static.
They are kind of built into the signature of your function. You don't have to go in the body of your function and set up static asserts. The function is already supporting concepts when you declare and define it, and this is really cool. Okay, this is our first syntax we can use to set up concepts for our function templates, using the requires clause after our template declaration and following that with whatever concept we want to enforce on our function template here. Please note that you can also use type traits directly in the requires clause here, and this is going to work. And this really says that all you really have to put after the requires clause is an expression that can be evaluated at compile time, but also results in a Boolean value. Once you satisfy these few requirements, you can really set up your concept however you want. You just have to be careful that the expression can be evaluated at compile time and that it evaluates to a Boolean value. And when the expression evaluates to true, the concept is going to succeed. If the expression evaluates to false, you're going to get a compiler error because the concept is not satisfied. This is how these things work. Now that we have seen the first syntax, I think it is big time we looked at the second way you can set up concepts.
Oh boy.
And that's going to be in your template declaration. You're going to say template, put in your angle brackets, and inside, instead of saying type name T like we have been doing all along, you just specify your concept directly and say the template parameter like this. Once you do
what is
this,
0.1 plus 0.2?
On this
0.3? I feel like there's a trick question
to
here.
really do the same thing. We also have a third syntax we can use if we use auto to set up our function templates. And the way this works is to just add your concept in front of the auto keyword. And once you do this, the compiler is going to enforce for the first parameter and the second parameter to this function to satisfy the integral concepts. So if you have to use auto to set up function templates, this is how you can use concepts to constrain ways in which people use your function. We still have another way we can use concepts in C++, and this is how you do it. You specify your template declaration like we have been doing all along. You specify your function template, but after the parameter list, as we see here, you're going to put your requires clause, and you can put that in this place here.
All of these different syntaxes should do the same thing.
There are many syntaxes
that
to process
seems
for
like
the
a
first
lot.
time, but some of these syntaxes are going to work better in some situations, and they are there just to make it flexible for you to use concepts in your C++ code. Okay, now that we have seen different ways we can set up concepts for our function templates, I think it is big time we headed over to Visual Studio Code and tried them out. Okay, here we are in our working folder.
Oh boy. Okay.
The current chapter is concepts. The current lecture is using concepts. We're going to grab our template files. We are going to put them in place. And we are going to open this thing in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. We do that. This is going to open our folder. We're going to open up our main CPP file and close the sidebar here. And we're going to clean things up a little bit. And we're going to set up our function template, which is going to add two numbers. We already know how to do that. So we're going to say template type name, and it's going to have a template parameter of T. Then we're going to set up the function like we have been doing all along. We're going to say add. We're going to say TA and TB, and this is going to return the sum of A and B. Once you have the function in, we can go in the main function and set up code that would call this function. And if we try to compile this program, it is going to work now because we are not placing any constraints on this function template here. Let's try to build with GCC like we have been doing.
Holy smokes, he just copied a bunch of stuff in. So let me get all that shit. Oh boy. Damn, doing big brain stuff today. Are we doing big? Is it big brain stuff? Oh, concepts. Hard? Is it? Are they supposed to be hard? Oh god. I haven't even really started with them. We just like got the intro lecture out of the way. And now I have to get everything that he can just copy in for the results for the purpose of the lesson. Let's add a 0, a 1. Boom. Concepts are big brain stuff. Oh boy. Here's hoping that it goes as well as yesterday. Result A. And then we have our static cast. This is also going to be a crash course in static cast for me because we have not messed with this at all. I don't know why it was suddenly introduced with no fanfare. Like we have, he mentions, oh, we did this last chapter, but like that's a result of this being I think it's cut from a bunch of other courses, or a lot of smaller what are they called? Smaller lessons that we haven't that were, I guess, decided it was too much. You are learning wrong. Oh boy. I believe in you, playa. I'm gonna do my darndest, believe it or not. And if I'm wrong, then I will learn it painfully, I guess. Because that's the only way I can ever learn. I need I need to make terrible mistakes. Terrible, horrible, no good, very bad mistakes. We do result B std end line double C0. So if I'm not mistaken, this one in the lecture, the doubles were the ones that shouldn't work because they were too they don't satisfy the template, right? STD integral type not satisfied. Result C equals add C underscore 0 C underscore 1. Because, like, hypothetically, all of these should try to call this thing. No, but seriously, you're literally in tutorial hell. Am I? is it a problem?
And set up code that would call this function. And if we try to compile this program, it is going to work now because we are not placing any constraints on this function template here. Let's try to build with GCC like we have been doing all along. You see, it is going to build. Okay,
Ooh.
you see the build is...
Hold on. My, uno momento. It appears this. There we go. I mean, Google tutorial hell later on. You shouldn't copy the code you see in the tutorial. Instead, you should make a tiny little variation of it. I mean, I'm sure that it would. I'm sure that would be something that someone smarter than I could just do. Right. Okay, here we go. So, GCC. All right.
It's good, build finished successfully. And if we want, we can run this application and it is going to print result A, result B. Let's take this out because we haven't done this yet. But it's not going to print result C, but if we want, we can really print it. It's going to work. So let's put that in and we're going to say result.
Is it? I was under the impression that it was going to give us a problem. Let's see. Don't see.
Result C and print result C here. And build again. Let's build now to take this into account. Build is good. We can bring up a terminal to try this out and we can clear and run rooster. Now you see result A is 30 because that's the sum of A and B here. Result B should be 16, which is what we have. Result C is 13, which is what we should get by adding these two double variables.
You're underplaying yourself. You're totally capable of doing that. In fact, you must be able to do that, and then at some point you will feel completely stuck. I escaped tutorial hell. We'll see eventually. I usually just try to make sure my shit looks exactly like his so that when I try to evaluate why I did something wrong or why something happened, I can try to figure it out. So with this thing, so we saw this exact code in the lecture portion at the very beginning, and so if my understanding of what static cast is doing here is correct, it's converting the result A, because these are characters, which is really weird to me. but it seems like it's converting these to integers, and then printing that result. And I mean that makes sense to do because we're adding, and then this is just adding integers, and then this one I think is automatically converting it to an integer. Or maybe not converting it to an integer, but it's not doing a it's not showing like any decimals. So I'm not sure whether it's doing doubles still for this. Char is actually an int. Then why does it have a different why is it initialized differently if that's the case? I was kind of under the impression that this would be like a capital J if you had it as char.
Now, we wanted to constrain this function
It's
to
a type
only
definition
work
for
if somebody
short int or
passes
short int
integral
depending on
types
your
in.
OS.
When we put that constraint in place, it is going to work if we add up two character variables because they are
See stuff. Did you
integral
cover type
types.
def?
It's going to work if we add up two
I think we
integer
did some
variables
some type definition stuff like near the beginning, but not a whole. I mean, it was stuff like looking at how much memory a like a char takes, or how much an integer takes, a double, and there was like double long longs, but not like a whole lot, I don't think.
they are integral types. But once we hit this guy here with the double variables, we should get a compiler error because the constraint is not satisfied. Let's do that. We're going to comment the double thing first because we want to really isolate it and see the compiler error that we get. And we're going to add a constraint to our function template using concepts. Okay, if you want to use concepts in C++20, the first thing you need to do is to include the library that gives us access to concepts. And we're going to do that by saying include concepts. This is easy. Now that we have this in, we're going to use the first syntax we saw in the slides, and we're going to add a requires clause after the template declaration, and we're going to say std integral, and we're going to say the template parameter here. I think this is the syntax. Okay, watch what happens if we do this. Down in the code, we are calling the function.
Oh, hold on. Yes, std integral t.
Okay, watch what happens if we do this. Down in the code, we are calling the function with char types and integer types. So this is going to compile fine because the concept here is satisfied. This concept is going to enforce for the template parameters we call our function template with to be integral types. Let's build and see if we get to compile successfully. You see build finished good. Everything is going to work, and if we run our program, we should see result A and result B printed out. Let's run the program. We see our result here. Now we're going to comment out the others and leave in the double example, and we're going to uncomment that. And I want you to see the problem we get when we try to use our function template with double variables here. You see, Visual Studio Code is already complaining. It is saying there is something wrong. If we look at the problems tab, it's going to say no instance of function template.
How goes the war?
The argument list.
It goes well.
This is really not descriptive enough. But the problem is our concept is not satisfied by calling our function template with double types, because we clearly said that we want the function to only be called with integral types. Let's build our program. We're going to pass this through GCC, and we're going to get a compiler error that says that some concept was unsatisfied. And we see in function main use of function tadd with double with unsatisfied constraints. And this is really clear. When we see an error like this, we will go and look at the constraints that the function has, and we're going to see if we satisfied those constraints by calling like we did in the main function here. And we will know that the function doesn't support non-integral types, and we will fix this problem. This is really how concepts can help in writing safer function templates. Now that we have seen the first syntax, I think it is big time we looked at the other syntaxes. So let's do that. Let's copy the code here because we're going to be reusing this a couple of times and adapt.
Okay. So, what was it? We're looking at with this. What I'm taking away from it is so double is not like an integral type, which I don't know if I don't know if it's been covered and I've just forgotten, but like I don't know exactly what integral types are. But apparently, so character and int being the same thing are the same type. C++ as a first language is more like a genocide than a war, but I believe in you. Is it? I've kind of been. I mean, so far it hasn't been like so bad. I mean, it's not like easy or anything, but it's not been like oh my god, I can't understand any of this.
Instead of typing this entire thing. The second syntax involves getting rid of the requires clause altogether and just using the concept instead of type name here. So we're going to say std integral, and this is going to be enough. This is going to tell the compiler to enforce this concept for this function call for all the template parameters that go in the place of t here. I hope this makes sense. Now, if we go back, you see that we still have our squiggly lines here. If we try to compile,
still doesn't
we
like
will
it.
get the same compiler error. Okay, and you see we have the same compiler error function add t called with unsatisfied constraints. I think if we go down, we're going to see even more stuff out of this. It's going to say required the satisfaction of std integral with t, but now we are trying to call this with double. So this is really going to lead to a compiler error. So this is the second syntax, and it is going to do the same thing. Now that we have seen this, we also have a third way we can do this, and that's through the auto mechanism. Let's set up a function using auto. So we're going to say auto add, auto A, and auto B. We have seen that we can do that in the last chapter, and we're going to return A and B, A plus B I should say. If we do this, you see that the squiggly line goes away, and we can add this.
Hold on, what does this look like? Should be the same, kind of similar to what we've seen before. Yeah, it's just return A and B. This is really easy. This one seems like the simplest by far. Syntax 3. I'd post a link proving why C++ is complicated, but I don't think that links are allowed. It doesn't, YouTube doesn't like links. I think I've specifically allowed them on Twitch. But, so we have this one. But I've heard C++ is not the easiest one to start with. Like I think it's been brought up before, but like I think Python is supposed to be the easiest one to learn. It like just intuitively apparently makes more sense. This one still has the C++ is not easy in general. Yeah, I would not say it's easy. Yeah, I don't think I'd ever say that this is easy. Like all of this, the only reason any of this makes sense to me, even something as simple as this, is because I watched like the first hour, 2 hours of this video. It's like, oh, I understand what's going on here. We're printing stuff. We're putting stuff to the terminal. You know, this is just like a random text that we created that we want to put there, but then this is actually a result of this, and this comes from this function that comes from taking these two things and running it through this. You know, hypothetically, this one doesn't work. Obviously, that's like the point of this demonstration. But you know what I mean.
Say, if we do this, You see that the squiggly line goes away, and we can add these things up and
Oh,
print the result. The return type is going to be deduced by the compiler automatically. But know that this is going to generate a function template behind the
does
scenes.
it?
This is just a nicer syntax we have to use.
How could I post this link? It's just an SVG page. Um, could you make? Is there any way you could just like uh remove like the dots in it or something, and then just replace them with like spaces or some shit, and I can change I can add shit in as necessary. Yeah, this is correct, right? Auto add, auto A, auto B. No matching function call for add. No matching function call for add. Double address, double address. Candidate template ignored. Constraints not satisfied with T equals double. Semantic issue. Is that just... Are you sure? Looks like this worked. Yeah, I guess it was from the last one or something.
Auto to set up functions that work for multiple types. Let's build and see how GCC handles this. The build is good because we have no constraints here. And if we run our program, it's going to work. It's going to give us 13 as the sum of 11.1 and 1.9.
Did you get any Rustations in your chat yet? Is that the name for people who know Rust? As far as I'm aware, no, not beyond. Like, I think maybe. I think I have. Maybe one of my friends has used Rust. Maybe, but I'd have to ask them and get clarification on whether that was the case. No, they fucking praise Rust like a cult. I mean, I haven't had anybody who's come in and like extolled the virtues of Rust to me and been like, "Oh yes, Rust is the greatest thing ever." Like at most, I've gotten like secondhand exposure to it. I know that was it fucking. There was there's another VTuber. I want to say it was Jelly, Hoshiumi type, who fucking did Rust on like a on like an anniversary stream or some shit. But that's nobody told you the type safety. Praise the type safety. No, not as far as nothing like that. I've been told that I've been told to check out like memory safe languages, but that's my understanding. That's the most I've gotten as far as like, hey, you should check this other thing out.
But we can also place constraints on this function here. And you do that by specifying your concept in front of the auto keyword here. So for example, we can say std integral and std integral for the second parameter here. Let's say that. And once we do this, if we go down, we should see our squiggly line on the call of the function here. Because now, the way we...
Does this even work? Concept template std integral is not a type name.
see our...
Did I misspell it or something? Oh, it's got to be also auto A. Okay. It's got to be std integral auto. That's what I get for not reading. Memory safe languages. That's Rustation talk. Oh no. Hold on. I'm gonna shoot my friend a DM. I'm gonna ask him. Are you a Rustation? All right. If I get a response, then we'll know.
squiggly line on the call of the function here, because now the way we are calling this function is not valid. The function clearly says that it wants to be called only with arguments that satisfy this concept here. If we try to build again with GCC, we're going to get the same compiler
get the same error as
Let's
before,
do that.
right?
And it's going to say use function with unsatisfied constraints. It's the same error. And if we go down, we should see that it requires the integral concept to be satisfied here. So this is the third syntax you can use if you happen to be using the auto syntax for your function templates. Let's comment this out because we still have another syntax we need to learn about. This is going to be our syntax 3, and we're going to comment this out. And the last one involves just leaving in our function template. Let's copy this because I don't want to type this again. We're going to go down and say syntax 4 and put in our function template. We're going to take this requires clause, we're going to cut it out, and we're going to put it after the function parameter list like this. And this is going to be valid C++ syntax to enforce a...
What the fuck? So do like this. Requires std integral. And then it has that. Okay, so I get what the response I got was no, I do not code in Rust. So that's there's our answer.
concept on your function template. If we go down, you see we have this wiggly line, and I should prove that this works with other integral types here. Let's just comment out the double line here and uncomment the other we had for car and ent. If we try to build this program now, it is going to build fine because the constraints are satisfied. But
all right, let's make sure that that works properly. Boom, boom. The Rustaceans disguise themselves just like any other cult. They will first talk about how move semantics are great, right? What if everything was like that? Am I supposed to be afraid? Oh no. I've heard of some of people doing some like people trying to extol the virtues of different languages, but I don't think I've ever had anybody come at me with Rust being like their number one favorite. There's a really cool therapy club for people like you and me. Oh no. Oh my god.
But the moment we uncomment the calls with double types, we're going to get a squiggly line, which is a good warning that we have a problem. But if we ignore the squiggly lines and just build with GCC, we're going to get the same compiler error. And it's going to say that to call our function, we need to satisfy the integral concept for the arguments that we pass here. And the double arguments we're passing in here are violating our concept, so we get a compiler error. This is really how you can use concepts in C++. I tried and came up with simple examples to show you different syntaxes you can use concepts with, and this is really it. Try to get yourself familiar with these syntaxes, and it's not going to be really hard to use concepts in your C++ programs. Okay, this is really all I had to share in terms of the syntaxes you can use with C++ 20 concepts. If you go to the documentation, you're going to have more information about this, but we're going to do a few more lectures to really drive these things home. For now, you can come to CPP reference here and see more concepts that you can use. We have a lot of this, and we can really use this to tune our function templates however we want. Okay, for example, you see our integral concepts, you see a floating point concepts, and there are even more that are usable with classes, but we haven't learned about classes yet. And
we have not.
That starting
that's
in
not.
Next chapter.
That's next chapter, man.
To be familiar with concepts that were introduced in C++ 20. And here is another piece of documentation you can look at all this just to complement what we are talking about in this chapter. But I wouldn't recommend reading this just yet because it's just going to confuse you. There is a lot of things we still need to learn to really be able to understand this. So try to go through this chapter, and I am going to try and break this down in ways that you can understand this. The main message is that there are more concepts here you can try in your
Hey,
C++
check out this book.
code
It's a bit
if
weird.
it makes sense
If
for the
you read it
problem you are
through
trying to
it,
solve
you'll
with C++.
start understanding
We are going to stop
Rustlang
here in
org
this
book. Oh
lecture.
my
In the
god.
next one, we're going to show you how you can set up your own concepts in C++. Go ahead and finish up here and meet me there. In this lecture,
Are you sure that you're not you're not yourself one of these rustaceans trying to worm your way in and be super you're trying to be so friendly and so like, oh man, like wouldn't that be great, aren't yeah look, aren't those guys kind of funny, those rustaceans? Oh man, anyways, here, check out this thing. No, templates are great. Oh no, it's over. Oh, what am I gonna do? Oh man, okay, we need to I think so there's a bunch of different stuff here. I think even though this one I haven't used a whole lot, I think I'm gonna go ahead and make a new folder. We're gonna start put the contents of this bad boy in there. Do these, file, open folder. Boom, look at that. Starting fresh. We're gonna build our own concepts now, apparently. Just kidding, I'm not a rustacean, especially since you earlier mentioned that you want to do game dev. I mean, yeah, that is kind of the ultimate goal with this stuff. We'll see if it ever comes to fruition, but like, I mean, that is also part of the reason that I went with C++ is because I had used I like 2 years ago or something, I had done like some very basic stuff with Unreal, which used C++. So I was like, well, fuck it. Let's go with the thing that I already had installed and have some familiarity with. Some passing, like, oh, look, they tricked me into building a function. By the way, C++ is not for game dev, I'm sorry. That's fine. I mean, from what I understand, like I've talked to a few different people who use different languages, like it's for game engine dev. Oh boy. I mean, that's also fine. That's also cool too. Anything is better than fucking making Pong and goddamn, was it Java or Python, whatever the fuck I did in high school. It was very weird. Get rid of this thing.
we're going to see how you can build your own concepts.
Let's build our own
And this is
concept.
going to bring us into the second part of concepts we can
Pie
use
game.
in C++. In the last lecture, we used
I don't even
the
think we had
concepts
anything like
from
that.
the
It was
standard
like
library that are
I was
built
like
into
straight
the
up drawing the shit on the
programming
screen.
language, starting in C++.
It was weird.
In this
I
one,
don't
we're going to
remember
be building
very well what
our
I did.
own concepts. And without waiting anymore, let's see how you can do that. And this is the syntax you can use to do that, and it is really simple. The way you do that, you say a template declaration specifying the template
Scratch.
parameter you
Oh
want
no,
to
it wasn't.
constrain,
It wasn't
and
Scratch.
then you say concept. You say the
I remember
keyword
Scratch.
concept, you give your concept a name, you put the equal sign after that, and then you're going to specify the requirements for your concept. So for example, here we are using a type trait to specify.
There was another one that I preferred to Scratch. I think it was called like Alice or something like that.
For this concept here. And what this is going to do is to enforce for our template parameter to only be integral. If it's not integral, we're going to get a compiler error. And one thing I should tell you is that the std integral concept is exactly built like this in the C++ standard library. This is really cool. So if you want to set up your own concept and you want to do that using type traits, you can do that like this, and it is going to enforce for your template
C++
parameters
is quintessential
to
game
satisfy
dev.
that
Most
type
engines are built on C++,
trait. Or to
and
be
most
exact,
multiplayer
the
netcode is
concept
built in
going
C++.
to be satisfied
Most game dev
when
jobs
the
are C++.
type trait evaluates to true. If the type trait evaluates
I mean,
to false at compile time,
I know
the
that
concept is not going to be satisfied.
I know it's useful
That's another way to
regardless
look at that. Down here
of
we
whether
have
it's
another
specifically
syntax
good
we
for
can
game
use
dev.
if we have multiple
But like the
statements in our concept, All you have to do
I've
is
learned like,
specify the concept
what was
keyword,
it? Unity
you
was like
give it
C
a
sharp,
name, you put the equal
AAA
sign,
game dev, which
and
I find
then
a
you
very
add
sad
a
career path.
requires clause.
Yeah.
The requires clause is going to specify the template parameters for which you want to enforce your concept. And then you're going to put a pair of curly braces, and inside that, you're going to specify the syntax you want your concept to satisfy. For example, here we want for the two parameters to be supporting the multiplication operator. If this multiplication operator is not supported for the template parameters that we pass, the concept is going to fail. And again, I should emphasize that this doesn't check for the value of a multiplied by b. It's just going to enforce for the syntax to be supported. So for example, if you call a function template with this concept and you try to pass in integers, it's going to work because you can multiply integers. But if you pass two strings, this is going to fail because it doesn't really make sense to multiply strings. Okay, this is the syntax. Now we only have one statement to enforce inside, but if you want, you can even put more statements. If you go down here, we have another example called incrementable. This is going to require for the template parameter to be incrementable. We specify the concept keyword, we say the concept name, we put in our equal sign, and then we say requires, we put on template parameter and put in our requirements. For any template parameter that is using this concept, the syntax here must make sense. So you must be able to take the value that you get from here and, for example, say I plus equals 1. This is going to be valid syntax. You're going to say plus plus a and plus plus b. All these are going to be valid C++ syntaxes for the template parameter that you try to call this function template with. And if this doesn't work, you're going to get a compiler error because your template argument isn't really satisfying this concept. So
I'm not gonna lie, guys. This section with like building it is kind of going over my head a little bit. I'm not quite sure. I'm hoping that when I get to the practical portion, I can like, you know, fuck with it and like see if it makes more sense then. But as of right now, this is going kind of over my head. Still not home, Sag. Unfortunate. Is multiplayer netcode really mostly built in C++? I'd imagine C# is used more, right? C++ is not very lucrative because it's so hard. It's lucrative for the programmer, not the company. Yeah, C++, I've heard C++ is like the is not, I don't want to say like premier language, but I've heard it's like a very popular and very wanted language by a lot of companies. Actually, one of the things I thought would be fun to do is after completing this video, there was some surprise yesterday when we mentioned that concepts were up next, and like classes are so far down. Like the first time I saw classes was where is it? It was under this one definition rule. That was the first time we saw them. But it was like, it was almost exclusively as a, hey, we're going to do this and demonstrate why the one definition rule still works, even across these different things. Even junior C++ devs are paid well, except for game devs. Oh, damn. Unfortunate. All right.
So this is really how you can set up your own concepts in C++. Once you have your own
Except
concepts
game
set
devs.
up, you can use them
Ain't
like
that
we
just
have
the
been
truth?
using the other concepts from the C++ standard library. For example, we can use syntax 1 to put a requires clause
Back
and
to the
say
Call
that
of
we
Duty
want to
mines with you.
satisfy our own concept. With this particular syntax, you will have to put in these angle brackets and put your template parameter inside. This is the syntax you have to use. You can also use syntax 2 and specify my integral directly in these angle brackets in your template declaration, and this is also going to work. We can even use this with the auto syntax for our function templates. It is going to work. Okay, now that you have seen this, I think it is time we headed over to Visual Studio Code and play with this a little more. Okay, here we are in our
Oh
working folder.
boy.
The current project
Please, for
is
the love of
building
God,
your
let
own
me mess with it,
concepts.
because I
We're going
need
to
to,
grab our
if I want to
template
understand what the hell
files
you
like
just
we
talked
always
about,
do,
Mr.
and we're going to
Gakwaya.
put them in place. And we're going to open this thing in Visual Studio Code. Let's do that. We have our project open here, or folder, I should say. We're going to clean this up a little bit, and we're going to include our concepts library, and we wanted to set up our own concept. The first syntax we're going to see is by using type traits, and we're going to say template type name t, and we're going to say this concept we want this template parameter to satisfy. We're going to say concept, and we're going to say my integral, which is going to be the name of our concept. We're going to put an equal sign, and then we're going to say std integral v and specify that we want this type trait to be satisfied for this concept here. And after this, we need to put in our semicolon, and I think we need to include the type traits library because we are using that. We should say std is integral. So sorry for that. And this is going to work now. Okay, now that we have the concept set up, we can use it like...
Hey, you know what? I might actually be wrong. That's how the industry was a while ago, but it was mostly very inexperienced developers because of bad management. Cough, EA cough. Could have changed now. I mean, uh, if I was in it for the money, I probably wouldn't be looking at game dev as like anything, because from what I understand, like it is not a it's not a very lucrative thing unless you like get to unless you're one of like the executives at like name your favorite fucking company, right? Like, oh yeah, I work as a stockholder for Riot Games. Like, oh, fantastic. I own stock in Tencent. If I was in it for the money, I would have been a scumbag lawyer. If I was in it for the money, I probably would have continued working for the government. Oh god, that shit was stupid.
we have been using other concepts. For example, we can set up a function which is going to add up two numbers, and it is going to use this concept here. We have
So why am I getting this? Namespace std has no member integral v. Oh, is it supposed to be is integral v? Yep, that's the problem. Got it. I unfucked my problem. Let's open the terminal.
multiple syntaxes we can use. So let's go down and try this out. We're going to say template and say type name t, and we're going to require this concept to be satisfied for our function template. We saw that we could use the requires clause here and say my integral and say the template parameter. We want to enforce this on, and after this we're going to just put in our function template. We're going to say add what we have been doing all along in the last lecture. We're going to say ta and tb, and we're going to return a plus b. Now this function is going to support our concept. Let's go down and set up two variables. We're going to say int x, and we're going to say 6, for example, and int y, and we're going to make this a 7. Why not? And we're going to say add x and y. Once we do this, you see that we have no problem because the concept is satisfied. For the arguments that we are passing in here, the concept is satisfied because the type trait here is going to return true for this type here because it is an integral type. When the type trait returns true, then the concept is going to be satisfied. If the type trait returns false, the concept is going to fail. Let's try and build and really drive this home. You see that the build is good, our function is working. So the function template instance for this call here is going to be successfully generated, and we're going to call it when the program runs. Now, let's change the type of these guys to double and try to violate our concept and make it fail. Once we do this, you see the call here has a squiggly line, and Visual Studio Code is not going to say that it is a concept problem, which is a shame. But we can still run this through the compiler, and the compiler is going to tell us what is wrong. So it's going to say use of function
crustaceans
with unsatisfied constraints. And if we go down, we're going to see the exact constraints we violated.
So this is the same problem that we had last time, right? where when we did this, it doesn't run because we violated the constraints. Man, you should try seafood. I have tried, but it's not really for me. Oh my god. Skill issue. We're gonna run into the oh god. One day I'm gonna finish up this video, and I'm just gonna go straight into R or some fucking other nonsense. It's like, yeah, all right, guys. So let's do something. Let's go. Fuck it. We're going back to punch cards, baby. Let's learn how to punch card code.
Required for the satisfaction of my integral with t. We are calling this with double, and double is going to...
Hold on, I want to see this. Where is it? It says requires my integral t. There we go. Bro, let's learn COBOL. Fuck it, do assembly. Oh my god. It's like, yeah, I'm just gonna... I started with C++, and then I immediately went into some crazy fucking shit. it's I went and learned a language that was designed oh god, I'm gonna go into... What oh, fucking... I'm gonna learn how to make Temple OS. I'm gonna just be Terry Davis too. I actually learned assembly for a silly, simple reverse engineering things. That would be that seems like a good reason to learn it. It seems good to like have an understanding of things like assembly.
To evaluate this to false. Hopefully you can see that you can really set up your own concepts using this syntax here. And we can use our concept with all the syntaxes we have seen in the last lecture. So for example, we can take out the requires clause altogether here and say my integral in the template declaration here. So we're going to say my integral. And if we do this, we're going to fail again because the concept is not going to be satisfied. We're going to have the same problem. We can change the syntax to use the auto syntax, but before we do that, let's change this back to type name t, and then put our requires clause after the parameter list of our function template. We're going to say requires, and we're going to say my integral, and specify the template parameter. And this is a valid function template with a concept applied to it. And if we build again, we're going to get the same compiler error. So you see the same error. And we can use the auto syntax.
Wow, programming is so hard, guy. Doing fucking common business-oriented language.
We're going to take out the requires clause here. And we're going to change our t to auto. And the way we do that, we're going to say std. No std. We are using our own concept. So we're going to say my integral auto. This is going to work. And we're going to say my integral auto and my integral auto here. The moment we do this, you see that we have squiggly lines here because our concept is violated. But if we try and build again, we're going to use GCC to do that. The build is going to fail. You see that the same concept is violated. And we are able to use our concept throughout the 4 syntaxes that we saw in the last lecture. And this is really cool. Now that we have this, we're going to comment this out, and we're going to see that we can set up concepts that have requirements spanning multiple statements or multiple lines. Okay, let's go down and do that. Suppose we want to set up a concept that is going to enforce for the template parameters to be multipliable with the multiplication operator we have here.
Okay. Template, type name t, concept, multipliable, requires t a times b. Huh. Common business-oriented language. I don't think I've ever heard of that one. Why is it? That doesn't tell me what the hell it's supposed to be. Like business-oriented language. What does a business-oriented programming language look like? Or like used for even? COBOL. But yeah, but like, but why though? but why? Like, I know that I know most languages can be applied to a lot of different things, right? You know, if you really wanted, you could probably make I, I've I've seen videos of people making like their own fucking graphics engines and game engines and shit because it's an interesting concept, but like what is a business oriented language? Common business oriented language. Is it supposed to be like fucking common in like in like fantasy game terms essentially? It's like, yeah, I speak common. Fucking everyone speaks common. It was made for Corpo Bros in 1959 when all languages were for super mathematicians. Our banks still use COBOL because they're trapped. Oh no! The banks! Who will think about the banks? Some good idea fairy bit some executive back in 1962, and ever since Chase has been chained to this fucking demon known as COBOL. That's fucking hilarious.
We can use this syntax here. We're going to put in our template
That's
declaration, we're going to say concept, we're going to say the concept name, we're going to put in an equal sign, and then we're going to put in a requires clause with our template parameters n. And after that, we're going to put a pair of curly braces, and inside the curlies, we're going to put the requirement. For example, in this case, we require for the template parameter here to support the multiplication operator between two of these types. If the multiplication operator is not supported, we're going to have a problem.
yeah. So
And
then this
this
one
is the
doesn't work with
concept that
like
is going to enforce that.
uh
One thing you should know is that this is just going to check that multiplying a and b is valid syntax. It's not going to check the value of a multiplied by b, and you should really understand this. Now that we have this n, we can set up a function to use these two guys. Why not use the function we have seen before to add two numbers? Let's do that. And we're going to put in our requires clause, and we're going to require now to support the multipliable concept, and we're going to specify our template parameter. We have the concept n, so we can use that to do whatever we want. Now we're going to say t add, and we're going to say ta and tb, and we're going to return a plus b. This is the same function we've been using all along. Okay, now we have our concept in place, and we have a function template that is going to use this concept. Let's see if we can add up x and y and see what we get. We're going to build with GCC. We're going to see that the build is going to be good because our...
run. Does this work? Oh, looks like it does. I guess the thing was just to not updating or whatever. And the 492-year-olds that know COBOL are making $500 million a year. I mean, for 500 million a year, maybe it isn't so bad to learn COBOL. There's only 4 of them, and if they're 92, that means they're gonna die soon. So like within a couple of years, I could be making 2 billion a year, right? If I just take all 4 of their jobs. Because let's be realistic, what are the odds they actually have to do anything at 92? What are the odds, right? I mean, it's probably not too bad. You know what I mean? It's just whatever.
Concept here is satisfied. We are passing double types for our function template, and it is legal
It is.
to multiply
You can
two
multiply
double
them.
variables. If we multiply two doubles, we're going to get a value, and that's going to be valid C++ syntax. But let's see what happens if we try to change our arguments.
Nobody can learn COBOL. We're just gonna have a 100% financial collapse. Oh fuck!
And we're going to say y is world. Why not? Let's go down and put in our semicolon. And the moment we do that, you see that we have a problem.
Yeah, so we can do, what was it? Boom. Oh my god. I actually used a hotkey for once in my life. this actually in the correct spot. String x. I mean, we've seen this concept of not being able to multiply strings together. So even though what we're doing, this I actually think is kind of interesting because this kind of is tying it together for me. So like what we're saying here, right, is without this thing, like I think if my understanding of this is if we comment this out, like let me actually try that. If I do this, then like the idea, well, this doesn't work anymore then, but basically what my understanding is, normally if you try to add strings together in this way, all that ends up happening is essentially creating one longer string, right? This one in this case saying hello world, like direct full all the way across, no spaces or anything like that. uh However, because we've created this concept, this thing that requires a multipliable, we can't multiply strings together. It doesn't work. And so even though what we're calling is an add function, this doesn't make any more this isn't allowed. It's not allowed to call this, which I think is kind of interesting.
And Visual Studio Code is not good at this yet, but if we go inside and run this through GCC, we're going to get that our concept is violated. Let's
Yeah,
look at the
that's
compiler error here.
this is the
It's going to
concept that's
say
being violated.
constraints not satisfied, and it's going to tell us that we are calling the add function with values that can't be multiplied. It's going to say the required expression here is invalid. And this is how you can set up a concept like this. And you can really use this to put constraints however you want on your function templates. But here we have just used one statement inside our concept here. We can even put in more. So to drive this home, we're going to set up another concept. Let's go down and put that in place. The concept is going to be called incrementable. It's going to be using the same syntax we saw here, but we're going to be putting a requirement on the template parameter here to support incrementation.
To support incrementation. Thick accents like that so often. Yeah. I remember when I wasn't even in high school. I completely skipped the first quarter of ninth grade, and I had to I was on what I was told to do is basically go on Khan Academy and follow that stuff. Okay, so we're doing this looks like between the two. Yeah. And that website also had a lot of really thick accents. Very good content, but very, very thick accents in some cases. I liked it. I was I didn't do nearly as much as I was supposed to. TA. So what does this do? So A in this case needs to be increment. Oh, wrong button. It was 1, and then this one is plus plus A plus plus. So our concept here is an incrementable. I owe my entire computer knowledge to YouTube captions. That's pretty. I mean, if they work, right? There's a lot of stuff that you can just find on YouTube that works surprisingly well for like teaching. All right, let's see. So this looks like it's correct. This is our incrementable.
And we want for every type that goes in the place of t here, we must be able to say a plus equals 1. This must be valid C++ syntax. We must be able to say plus
Sometimes
plus
the
a.
accent is
This
so
must
thick
be
that
valid
YouTube
C++
has an aneurysm.
syntax.
Yeah.
And we must be able to say a plus plus. This must be valid C++ syntax. Now that we have this, we can change our add function to use this concept. Why not? We're going to say incrementable. And now this function is going to be required to use things that we can increment on. And you see it is failing already because we can't really increment strings.
Yeah, you can't increment strings either.
So let's build and show you the compiler error. Okay,
I think it's interesting that I think it's interesting that you can add strings together. At least my understanding is that you can add strings together in this way, but incrementing them is different. And like it's not just adding one, it's a unique thing. Like I think that it's like because if you would have to add a it would be like adding the number 1 to it, but like not really. It's fucking weird. The concept of incrementing a string sounds funny to me. All right. Operator overloading. Operators are just functions you can define for each type. I think I don't remember if it was you or someone else who mentioned that you could do that before. Like I think the example we were talking about then is like you can if you can you like redefine the this symbol here, then you can you can turn the thing that we had before. You can turn this into something that makes sense for strings, but you have to redefine this operator. All right, actually, give me a second, guys. I need to take a quick leak. I'll be right back in like a minute or so.
Welcome to the throne of God, mortal.
Just a dadgum second. I just got back. What's going on? I heard a noise. Anna Laura 110. Appreciate the follow. I hope you enjoy your stay. Can I whip up some crazy commission artwork for streamers? Or I would. I mean, I haven't commissioned any art whatsoever. Somebody followed me. They're following me. Ah! You have no link to your Twitch and YouTube. Oh, I don't. Yeah, I'm not gonna lie. I think I've treated I've treated Twitch as my redheaded stepchild for so long. I have a part of the reason for that is just because I blatantly break the rules with the having both chats integrated together. So I don't put too much stock in it, but I also haven't. Here, I probably should put a link somewhere. I don't know. I think maybe after the stream, I'll go start putting that around my shit. Is that not allowed? Twitch, from what I understand, Twitch doesn't like it if you have both chats in the same like window. I think you can have them both on screen as long as it clearly shows which one is Twitch and which one is YouTube or whatever other service you're using, like Kick. But I'm also not. I I don't. It's funny. I have like 100 followers, a little bit more at this point, on Twitch, but I don't. I'm not a. I'm not a partner because I don't have 3 regular viewers on, on it, which is really funny to me. uh, anyway, I think part of that is because I'm on YouTube as well, and and so everyone wants to watch on YouTube because YouTube's video is just better. uh, all right. But yeah, I'll try to make sure I put some links to Twitch and vice versa. I think I have 1 link on Twitch to my YouTube. We'll see. So I need to make sure. Okay. What is this? All right. We're going to continue with these concepts. I think I'm kind of understanding what concepts are, right? Where we're basically it's. I mean, it's he's said it many times, but like the fact that I'm like finally processing it, it's a specification for your template, right? It doesn't seem too terribly complicated to understand. It's just, you know, remembering that it's a tool to use and using it. But yeah, like in this case, when we have our add template, uh, because we can't increment a string, then it doesn't work, which these things are all incrementation. All right, so let's continue.
Is not satisfied and the required expressions aren't valid. You see plus plus a is not valid, a plus plus is not valid, and a plus equals 1 should not also be valid, but we're not seeing that here. But hopefully you see the message here that our concept is failing here. If we comment out our strings here and uncomment double, all these operations we have here are supported for the double type. So we should not fail here if we try to compile this because the concept is going to be satisfied. Let's use the GCC compiler to build. You see the build is good now, and we can clear and we can bring up a terminal to really see this, that our binary was generated. Let's do the IR. We're going to see our rooster executable here, and if we go down, let's say done, we're going to see that if we build again to bring this in consideration, clear run rooster, the program was generated and it is really running because the concept here is satisfied with our call using double arguments here. Okay, so this is really all I set out to share with you guys in this lecture. I hope you know the syntaxes you can use to create your own concepts. You can either use type traits like we have seen here, and the syntax is to put the keyword concept, put in your concept name, put an equal sign, and then specify your type trait here. This is going to work. If you need something a little more complicated, then you're going to use this syntax here and put the requirements for your concept in these curly braces. You can either put one statement like we did here, or you can even put as many statements as you want. Just remember to end them with semicolons. And another thing you shouldn't really take lightly is that this is just going to check for syntax. It's not going to check for the value you get after you add 1 to a here, for example. It's not going to check for the value you get after you multiply b. It's just going to see that a multiply b is valid syntax for the types that our template parameter is using here. We are going to stop here in this lecture. In the next one, we're going to zoom in a little more.
Were the quizzes yesterday too painful for you to do some of them again?
Finish up here and meet me there.
On the contrary, I kind of enjoyed doing it, because partially because, you know, it made me feel big brain at the end there, when we got the last question or whatever correct. made me feel pretty smart about that. But also because it's also just a good exercise to make sure I am actually retaining this information and knowing what the hell I'm supposed to do. You know, and like making mistakes is one thing. Understand, like, because I think what I did initially, I just created three different functions that like it worked and it created and it solved it did the thing, but I didn't follow the instructions. It was not a template, right, initially. You know, and then we had to go through and like, okay, I was wrong, and then this one I was also wrong, you know, for different reasons this time. Yeah, so we're gonna go ahead and I do think it'd be fun to do some more of them. Project. Project 38, Project 38. I need to go rename all of my projects so that they're actually correct. Because I currently have them all as a project. Alright, we're going to go ahead and close this one file. We're going to open folder. This one's going to be 38. I kind of wish, and this is like a minor thing as well, but like I the FreeCodeCamp's quizzes are good, I imagine, if you've taken the lesson that precedes the quiz. Whereas the way we're doing it with just this one long video, this 0 to hero type shit, is very I don't think that the quizzes are designed for someone doing this. I could link one to you, but I think that it's something this video doesn't cover despite it being so important. I mean, how like what is it about? This one's zooming in on the requires clause. Okay. Yeah, we got about a half hour left of this one. Oh, we'll keep going.
In this lecture, we're going to learn about some more things we can do with our requires clause. But before we do that, let's look at
Why don't you
the
consider
kinds
reading
of requirements we
instead?
can.
What, like doing the reading lessons and doing those? Part of it is because I like listening. I like listening to the lesson and then having it like kind of explained to me. And if I need to, I can like go back and like listen to it again and it's like, okay, I can like is there a reason that I'm not understanding something that we're doing in the practical portion? Like with the lecture portions, I'm a little bit less keen to go back and re-listen. But then the reading ones, I feel like with reading, I don't know, I'm not very. I feel like I miss stuff when I read, and that I just do it. Um, I feel like I'd make mistakes with it. I don't know. It's it's not like a huge difference. I'm but at this point I'm like committed to the video. I think you should do summary and quiz for chapter 1, learn CPP. So, is that on the website or is like learn CPP a different thing? Learn CPP. Yeah, it looks like it's different. Oh wait, no. Chapter 1 summary and quiz. The 1.x. Yeah. This one's only like 3 questions long by the looks of it. Okay. Here, let's do this. All right. I want to finish this chapter today. This might take a little bit longer. But we can do but after I finish the chapter, doing the chapter 1 quiz, I don't think would be too bad. Because it looks like it's mostly just asking about like different, some really, I mean, older stuff that we covered near the beginning, which I guess makes sense because it's chapter 1.
Put in our requires clause. The first one is a simple requirement, which is what we have seen so far. We can also do a nested requirement, and we're going to learn about this in a minute. And we can do a compound requirement, which is going to allow us to specify more things about what we require for our concept. There are also type requirements, but these are really advanced for the scope of this course, so we're not going to talk about these in this course. What we're going to look at are these three first here. So let's look at a simple requirement. This is what we have seen already. Here we have our template declaration. We have a concept declared. The concept name is tinytype. We're going to put in our requires clause. We're going to put in our parameter list, and we're going to put in our curly braces. Inside the requires clause, we have a statement here which is going to enforce that size of t is less than 4. And what this really means, it's going to check that size of t, the syntax here is correct. And this can really throw people off. I have said this in the last lecture, but I set up this little example to really drive this home and show you that if you are not careful, your concepts are going to be really wrong.
Since the quizzes shouldn't take too long, I think you should do all of them until you don't understand. It's one thing to watch a video, it's another to actually write code, but I don't know. I mean, I'm not against doing it. I'm not gonna lie. Part of the main reason that I haven't done something like this so far is because I didn't know where to go looking for it, and it didn't seem like something that I'd be like, I'd need to. It wasn't something that I really considered that much. It was like, you know, but like if I'd been doing this on another like on the Learn CPP website or something, like if I was just reading the chapters, then I probably would have been just doing them. But part of the thing for me was just that this video is 31 hours, and it's a and I started with the concept of I'm gonna just do the video, and if it works, then great. If not, then I mean, probably on me, but still.
This is going to check for the syntax. So for example, if we call a function template with this concept with a car type, the concept is going to be satisfied.
If not, then
even
rip.
if
Yeah,
the
pretty
size
much.
of a car is less than 4, obviously, but that's not going to be the job of this concept here. This concept is not going to enforce for the expression here to evaluate to true. It's going to just check the syntax. And if you pass something smaller than a net in a function template with this concept, this is going to be valid C++ syntax, so the concept is going to work. So now you must be asking, how can I enforce for the value of this expression to be true using concept? Well, for that, you will have to use nested requirements. And a nested requirement is going to have another requires keyword inserted in front of it. Now, if you use the syntax like this, now this is going to check that size of t is actually less than 4. If it's not less than 4, this is going to return false here, and the concept is going to fail. And this is how you can use nested requirements to enforce for some expressions to be true in your requires clause. Another kind of requirement you can set up for your concept is the compound requirement. And this is going to allow you to check if something doesn't throw an exception. You can do that using the no except keyword, but we're not going to use this now because this is not in scope for what we can do at this point in the course. But you can also check the return type of an expression and enforce that it satisfies some type trait, for example. So here we are saying for our concept, and if we pass in 2 parameters, the syntax for adding A and B must be correct and supported for those types. But the result of A and B must also be convertible to int. And you can do something like this. And this is going to work. You can enforce these kinds of things using compound requirements. Okay, now that you know about these kinds of requirements you can put in your requires clause, let's head over to Visual Studio Code and play with this a little more. Okay, here we are in our working
Here's
folder.
hoping that makes a little bit more sense.
Zooming in on requires clause, we're going to grab our files and we're going to put them in place. And we're going
It seems like we're adding even more requirement or even more restrictions on our wow, I'm totally blanking on concept.
We're going to open that in Visual Studio Code pretty quick by dragging and dropping here.
Even more
open up our
restrictions on the templates.
The usual. We're going to close the pane here. We're going to clean things up a little bit. And we're going to include our concepts library. Let's do that. We are going to set up a simple concept. We're going to say template, and we're going to say what the concept is. The concept is going to be called tiny type, and we're going to say what makes this concept a tiny type. We're going to put in our requires clause, and we're going to put in the template parameter, call it t, why not? And we're going to put in our closing semicolon here. Now, what is going to make this concept a tiny type is that the size of the template parameter here is going to be less than 4. Let's suppose we are doing a function and we want it to use for integral types that are smaller than 4 bytes in memory. Suppose you want to do this and it is useful in the problem that you are trying to solve in C++. The way we can enforce this, we can say size of t is supposed to be less than 4. Let's say size of properly can't type can I. Okay,
so this is the one that he explained does not. If I'm not mistaken, this is the one that doesn't work properly. Or it was like less than or equal to 4. I think in the one that we saw. But I think the reason that this one isn't supposed to work is because all it does is it checks whether the syntax is valid, and it doesn't actually like set this as a parameter or as a requirement for this parameter. Or for the parameters regarding tiny type. Or Jesus, parameters. I'm using the wrong words. I think, but it's basically it needs the size of what the goal is to get size of for tiny types. Anything that we call a tiny type to be less than 4. Which I don't know if less than 4 would be like what short ints.
The moment we do this, you're going to see that this is valid C++ syntax. So we're not going to have any squiggly lines, but what you should know is that this is a simple requirement in C++ concepts. And what this is going to do, it's just going to enforce the syntax of what we do here. What we put here must be valid C++ syntax. So only enforces syntax. This is what you should really remember. Okay, now that we have this in, let's try it out and show you some problems you can really run into. We're going to set up 2 character variables. We're going to call the first one x. We're going to initialize this with 57. Why not? 67. And we're going to put in the other variable, which is going to be y, and it's going to have a 56n. You can put in whatever you want. Just make sure that you are within the range of a card type, which is between 0 and 255, if you remember. Okay, now that we have this n, I realize we don't have a function. We can try this on. Yeah. Let's set up another function pretty quick. We're going to say tiny type auto. We can do that. Oh. You already know this syntax. And we're going to say add tiny type auto a and a tiny type auto b. We can do that. And we're going to return a plus b. Now that we have this, let's say a and b down here and call this function. We're going to say x and y. And we're going to try and compile this program. And it is going to compile fine because the type we are using to call the function, which is car, its size is going to be less than 4. Okay, so this is going to work and it is going to compile. Let's build with GCC. You're going to see that the build is good. Let's try and change the type here to int. or even double. You know,
That was the
double
wrong
is
compiler.
8 bytes
Oops.
in memory. So we expect this to probably give us something wrong. Double type is 8 bytes in memory, so we expect the size of t here to be false, because the size of t is going to be 8, and 8 is not less than false. This is going to be false, so some might expect this concept here to fail. But let's try and really prove you wrong. We're going to build with GCC, and you see it's building successfully. What this is really doing is that with simple requirements like we have here, C++ is only going to enforce for this to be valid C++ syntax. And size of t is less than 4 is going to be valid C++ syntax even if this expression here evaluates to false. This is
Right.
not going.
That's what he was saying before, is that this doesn't actually set this as a requirement essentially for this value. Like we could have a double long and that would still be valid, even though because the code we've written in this area is not actually does not actually meet the requirements or meet our intent, is kind of my understanding. And we had to put, I think what he said in the lecture is that we have to make a second requires thing, because that creates I think he said it creates like a Boolean that if it evaluates to false, then like if that portion of it evaluates to false, then this is no longer, then it no longer is valid.
To enforce for the value of this expression to be false, you can't do that with simple requirements. What you will do is check that this is valid syntax.
Compound or complex
now,
requirement?
what do we do if we really want to enforce that size of t should be less than 4? If you want that, you should use nested requirements.
Nested.
And the syntax to do that is really simple. We can go down here and put that in. We're going to say requires. We're going to add a requires keyword in front of this. Then we're going to put our expression here. Let's copy it and put it in. I don't want to type this again. The moment we do this, now compilation is going to fail if we...
Hold on. Size of t is less than 4. And now this doesn't work, which is our intent, which is what's intended.
The moment we do this,
I think character wouldn't work either, because I think this is less than...
if we pass a type whose size
I think
is
character is 4.
And
character
let's try
and
and build again. You're going to see that the build is going to fail.
It's going to give us the same error we've had the last 3 times, where it's talking about it doesn't have our constraints not satisfied. That's the word I was thinking.
We're going to see required for the satisfaction of tiny type auto, and we passed in a double type whose size is 8 bytes in memory, and it is less than 4 bytes. You see the requirement here. It is not satisfied. We can do this using nested requirements. Okay, if we go down, for example, and change this to car, some people call this char, but I call this car. That's my habit. If we change this to car and try to build again, you're going to see that it is going to build fine. Because now, what is wrong here? Let's see.
It's because it's less than 4, not less than or equal to 4.
We are getting a compiler error here. What is the problem? It's going to say, let's go up and try to analyze this a little bit. It's saying deduced return type does not satisfy placeholder constraints.
Right.
And we are requiring for the return type of this guy to be tiny type. I think I know what the problem is. The problem is the arithmetic operations like the addition we're doing here are not supported for types which are smaller
is that so?
than int. Int is the smallest type we can use with arithmetic operations. So what the compiler is going to do is going to do implicit conversions from car
is 1 if I know.
And inside here, what we will have are going to be int. The result of this is going to be int, and the return type is going to be deduced to be int. But int is going to violate the requirement we have here, which is saying that the size of tiny type here should be less than 4, and the return of int is not less than 4. So we can try and fix this by putting an equal sign here, and I think it's going to work. Let's do that and build again. This is a good learning experience. And now you see that the build is going to work because now the return type is going to satisfy our requirements. So let's prove that we are getting an int out of this actually. We're going to do auto result, and we're going to say equal and grab the result of this guy. We should really prove these things. And after this, we're going to print the result. We can do that. And we can even go further and print the size of result here. So we're going to say size of result. Okay, now that we have this n, we can build with GCC, and the build is good. Don't mind this squiggly line. It is probably Visual Studio Code messing with us. You see that the build is good. We can now bring up a terminal and run this and see the size of the return type and really prove that the compiler turned that into an int, even if we called our function with car arguments. This is interesting. So clear and run rooster. Now we're going to see result is going to be 123, and the size of the result is 4, even if we passed in car types as our arguments. Okay, so hopefully this proves that you can set up nested requirements to enforce for the expression here to be checked. Another type of requirement you can do is a compound requirement. Let's put this in, and we're going to put...
Okay. That makes sense. So even if my understanding of this was off, or understanding of exactly what the problem was off, the solution that I found was or that I said, I think, was correct. I think I put it in and then I took it out until I put it back in. Okay. Oh boy. So this is nested requirement. So then all of this is going to be a compound requirement, apparently. Requirement. There we go.
Put in a simple example to drive this home. I think I should take this
Let's put in a simple example, surely, and then he just copies in all this text.
function and put that below our concepts. So a compound...
Okay, yeah. This is the actual template. And then this one is going to be the new thing. Let's do add template. Template. Jesus Christ, I can't type for shit today. Template. Dude, what's wrong with me? Type name T. And then we have concept. And this needs to be addable. So it requires TATB. So no except is optional. Now I'm not quite sure what no except is. I think he explained it during the lecture and I just didn't get it. I remember he mentioned it. No except. std convertible to int compound requirement. Doesn't throw exceptions, optional. And the result is convertible to int, optional. Now, I don't quite understand what exactly all this is.
Requirement looks like this. You put your expression in a curly's like this, and then you can even put requirements on the values of the expression. For example, we can enforce that the value of a plus b here should be convertible to int. If it's not convertible to int, the concept here is going to fail. This is a compound requirement. You can even put no except keywords in here, but we're not going to go this far because we haven't really learned about exceptions. So for now, I'm going to take this out. I just wanted you to be aware that you can do that. Now that we have this concept in, let's play with it and see how we can make it break things. We're going to change our concept to addable. Let's say addable here. And we're going to say addable. And we're going to put in our car types here. And it is going to still work because we can add 2 car variables, and this is going to work because we can add 2 car variables, and this is valid syntax. What we're going to get out of that is going to be an int, because remember, the compiler is going to insert implicit conversions from car to int because it can't really add 2 car types. Int
Right.
is the smallest thing you can do arithmetic operations on. So the result of this is going to be an int. So an int is convertible to an int. This is going to work. Let's build and show you that this is going to work. We're going to build this with the GCC. You see, build is good. We can try and run this and see what we get. After calling the function, we get result is 123, and this is going to be the size of 4 because we get an int.
Because it's an int.
Let's try and change this to double and see what we get. So double. Let's say double here. And if we
this is convertible to int, so this should work, right?
Adding up 2 doubles is going to give.
This is totally valid stuff, I think, right? Like, these can be converted to int. It's just not going to, if we have like a decimal, like if I do like 0.3 here, I mean, it'll add these up and the correct answer will be 123.3, but it's going to, I think it'll just spit out 123 the way that because it's not, because it's converting it to an integer, and integers don't have decimals. If my understanding of this is correct.
Give you a double, and we're going to return a double from this function.
Interesting. So it didn't actually convert it to an int.
Is convertible to an int. So we're going to return a double.
So it doesn't actually convert it to an int. It just needs to be convertible to an int. Right. That makes sense, actually. Because this doesn't actually say... I mean, this is a concept. It doesn't actually do anything, but in this case, all it's doing is... it creates a constraint on this thing, on our add template, right? Which this one did too, but it was a different constraint. In this case, it just needs to be convertible. So the double doesn't get converted to anything. It just needs to be able to be. That's fucking weird. I mean, it makes sense, but that's fucking weird, dude.
From this guy, and this should say 8 now, because that's what we are returning from the function here. Let's build with GCC. You see, the build is good. You can clear and run rooster. This is going to say size of result is 8, because now what we are returning is going to be a double from this function here, and double satisfies our concept.
Yeah, the concept, it must be convertible.
And what we get out of that is going to be a double, and a double is convertible to an int. Wow. This is going to work.
Wow.
Let's try and change our parameters here to string. We're going to comment out our x and y variables here, and we're going to set up 2 strings. We're going to say std string x, and we're going to say hello. And you know what we're going to say in y? We're going to say std string y, and we're going to say world. Why not? And the moment we do this, you see that we have a problem. Why do we have a problem? Because it is now a requirement for the result of A and B to be convertible to int. Remember that you can add up 2 strings. For example, you can say auto s and say x plus y. This is going to work because you can add up 2 strings and this is going to concatenate them. So this is valid syntax. Why are we failing here? Because we have a requirement for this to be convertible to an int, and a string isn't really convertible to an int, so this is going to fail. Let's build this program and show you that this is actually the case. We're going to see build finished with errors, and let's see the error we have. Okay, so constraints not satisfied. It's going to say required dissatisfaction of audible with auto here in requirement, and it's going to say A plus B does not satisfy the type requirement. Because what we get after adding A and B is not convertible to an int. And you see that here. A plus B convertible to an int, this is going to fail. Okay, so let's try and remove this requirement to convert to int and see that this actually works. We're going to remove this. I'm going to cut this out and try to build again. I am going to use GCC to build. And now you see that this is building because we no longer have the requirement of the return value of this expression, or result, I should say. The result of this function now doesn't have to be convertible to an AND. Okay, let's put this back because I want you to see this later as a reference. And now you know how you can use compound requirements to really put constraints on your function templates. This is really all we set out to do in this lecture. I hope you found it interesting. I think I should comment out these guys because I don't like to leave you with code that has compiler errors. Let's turn this back to double so that this works. We're going to build again. Okay, the build is good. And we are going to stop here in this lecture. In the next one, we're going to see how we can combine concepts and do some crazy things. Go ahead and finish up here and meet me there.
All right. We're gonna unfuck or I guess initially refuck, and now we're gonna unfuck. So this should be just the numbers. Terminal, run task, G++, roo. Yep, and then we get this thing. That was enlightening. I liked that. That felt very, I feel like the ideas behind these things kind of came together and made a little bit more sense for me. Because my initial suspicion was that this was just going to convert it to an int, and that did not, and that when that didn't happen, I was kind of surprised. But that also it makes perfect sense why it didn't, because all it is a concept explaining like it needs to be able to do this. All right, so we got logical combinations. How much are we got? So C++ 20 concepts and auto. Okay, we got another 15 minutes of this, and I'm hoping that I can. I kind of want to do it in time so I can get dinner by like 6. Here, actually, give me a second. There we go. Okay. Big brain. I mean, it feels like it's just very strict logic, right? Like I've made certain assumptions that were wrong, and then when they were proven wrong, the explanation for why it was wrong kind of was like, well, of course that makes sense. Concept, big brain concept. I'm curious why this lesson decides to go into concepts before it goes into classes ever. But like intro to classes, your first class, C++ constructors, defaulted constructors, setters and getters. I mean, this is going to be like our next like long section. Look how long that is. That's crazy. Anyways, we got like 15 minutes of this. Let's go.
In this lecture, we're going to see how we can combine concepts using logical operators. We can combine concepts using the AND operator and the OR operator, as you see here. Let's look at a simple example. Here we have a concept. It is tiny type we have seen before, and it's going to check that the size of the template parameter we pass is less than 4. It's going to enforce the syntax with a simple requirement, but it's also going to enforce for the value of this expression to be true. If the value is not true, the concept is going to fail, and we are using a nested requirement for this. So this is our concept here. Let's try and set up a function and see how we can combine this concept with other concepts. Here we have a function. It is going to return a t. The name of the function is func. It is taking in our parameter. And here we have the body of the function within these two curly braces. But what we have here is a concept we want to apply to this function here. And the first line here is going to show that we can combine concept like we do here. So this entire thing is going to be a logical combination of concepts. So we can require that the template parameter be either an integral type or a floating point type using the OR operator here.
Oh, we haven't messed with the OR operator.
The AND operator, as you see down here.
We haven't messed with those operators in a minute.
And we're going to require that the template parameter is both integral and a tiny type. And the compiler is going to enforce these things, as we are about to see in a minute when we hit Visual Studio Code. You can even specify your concepts in place. For example, the third line here is going to say, we require for the concept to be integral, so it should be an integral type, and we're going to specify our tiny type concept in place. You see, we are doing that right here in the function declaration. And this is going to work. This is a valid C++ syntax, but I don't recommend this because this is going to make your function declarations really ugly. So now that you know this, we're going to head over to Visual Studio Code and play with this a little more. It's just using the OR and AND operator to combine concepts. Okay, here we are in our working folder. The current project is combining concepts. We're going to grab our...
All right, let me... I can probably just make this work, right? Surely, probably. Yeah, we'll try to make this same file work.
Our template files pretty quick and put them in place. And we're going to open this in Visual Studio Code as we always do by dragging and dropping here. We have our file. We're going to open that up and close the left pane here. I don't like it. And we're going to include our concepts library. Let's do that. We have this in. The first thing we're going to do is to put in our tiny type concept here. So it is tiny type. It's going to require
so we have our tiny type
the
still.
syntax for size of t less
we don't
than
need to recreate this.
This is a simple requirement again. And we're going to require that this expression be true. And we're doing this using a nested requirement. Okay, now that we have this concept, we can combine this with other concepts. Let's use the same function we've been using all along. So we're going to say template type name t, and we're going to put in our requires clause. So we're going to say requires. We can use std integral and say t and say, or it should be std floating point. I think we have this in. This is a concept we have, which is built into the C++ standard library. We can use this.
All right, let me get that one real quick. I'm gonna... If something else is usable, then we will use it, but I want to make sure. I want to make sure that all our stuff is making sense. All this can be commented out. We don't need most of this main. This we'll probably add eventually, but for now it's whatever. So we have this one, and then we're creating our template type name T, not L. And it requires std integral T or std floating point T.
Now that we have this, we can then say the signature of our function tadd. It's going to add up ta and tb, and it's going to return the sum of a and b. Now, you can only call this function with either integers or floating points. If you try to deviate from this, the concept is going to fail, and we're going to get a compiler error. Let's go down and try this out. We're going to say int x and put in a 6, for example, and int y and put in a 4. And we're going to add this up. We're going to say add x and y. And if we do this, this is going to work because this is an integer, so the concept here is going to succeed. Let's build with GCC and show you that the build is good. The build is good, so no problem. We can change this to double. It is going to work because double is a floating point. Let's say double properly. And if we build again, the build is going to go through. But if we try and use, for example, a string, let's say std string, that's a string.
Wait, okay, no. My red lines were just to fuck with me, I guess. Clear. Alright.
And we're going to change this into double quotes. We can do that and say std string and put this in quotes again, double quotes. Okay, if we do this, you see we have a squiggly line. And if we build, we're going to have violated our concept because the parameters that we pass don't satisfy this concept. It's neither an integral type or a floating point type. And if we go up here, we're going to see that we have violated a concept constraint not satisfied, and it's going to say the concept that was not satisfied here, which is right here. Okay, you can combine two concepts using the OR operator, but we can also use the AND operator. Let's go down and try and put up a simple example that is going to do that. Now, what we're going to require for people to use this function is to satisfy both tiny type and integral. So we're going to say requires std integral. I think we have this n, and we're going to say and tiny type, and we're going to say our template parameter here. The moment we do this, and let's turn this back to being int, let's say int x, and put in a 7, what we had before, and int y, and say 4 or a 5, doesn't matter. If we do this, let's see our thing again. So tiny type requires for the size to be less or equal to 4. So int is going to work. This is going to build because the concept is going to be satisfied. It is both integral and tiny type. Let's build and see this run. You see the build is good, our concept is satisfied. But the moment we try
wait, I fucked something up. What did I fuck up? Ah, these. No, it should be fine, right? Okay, build finished successfully. Phew.
And use something that is greater than 4, we're going to have a problem.
Yeah, so if we use it like a
double, for example, we're going to change this to double and build. We expect compilation to fail because the type, which is double, doesn't satisfy the tiny type concept. And we're going to see that here. Okay, so we're going to see build finished with errors, and we're going to have a lengthy error here. But the meat of this is that we have a constraint which is not satisfied, and it is that for required for the satisfaction of std integral. So double is not going to satisfy this. I think double was a really bad example because it's not integral, so integral is going to fail. What if we pass in long int, okay, which is really an integral type, but it's not going to satisfy tiny type. So let's say long int, and we're going to build. Now we are going to violate. Let's use long int because I think long int is not large enough. So we're going to build. Now we're going to fail because tiny type is not satisfied. You see, required for the satisfaction of tiny type, and it's going to say size of t is less than 4 is not satisfied because guess what? The size of long int is greater than 4. You can try and prove that by taking out this guy here and saying stdcout size of long int. We're going to see this print out. And if we build now, we're not going to violate our concept because we're not calling the function. The build is going to be good. What we want to do is run the program and see the size of long int. We can do this. Rooster 8, the size of long int is 8, and it is going to violate our tiny type concept. Okay, you can do things like this and combine concepts, but we can even put our concepts in place. We can do something crazy and, for example, say, let's copy this, and we're going to go down and say requires integral, but we're going to put tiny type in place. For example, we're going to grab the requires clause here and copy it and put that in place of tiny type here. We're going to do this, and you're going to see that this is going to be valid C++ syntax.
Oh, that seems fucking awful. I hate that. I mean, it makes sense that this is allowed, but also I hate it. That's terrible. Because all it's doing is instead of it's like retyping a function for no reason, right? Like the reason that we created this concept in theory is so that we don't have to is so that we don't have to like define it multiple times. But like the fact that you can just kind of you can copy the yeah, you can copy the body of it essentially and create it again here. Yeah, I mean, long does not satisfy tiny type. It's very I'm not going to do it. It's basically
If we take out
basically the gist of that.
because it shouldn't be there. But look at this. This is really ugly. This is
Yeah,
going
it's
to make
fucking
your functions
hideous.
really hard to read, but it is going to work exactly the same way it did. If we call this function, we're going to violate tiny type. Let's do that. We're going to build with GCC.
It's the same error that we've
Let's
read
bring this
many,
up
many
so that
times
we can
now.
see what is wrong. Nested requirement size of t is not satisfied. This is a syntax you can use, but I don't really recommend this because this is going to make your code hard to read. And this is really all we set out to do in this lecture, looking at how we can combine our concepts using the AND operator.
I do think it's interesting that you can combine concepts.
Can
I completely
really
forgot about
use
these
in
operators.
all the syntaxes for concepts we have seen, but I just used this in this lecture because it is simpler to show. We are going to stop here in this lecture. The next one, we're going to look at concepts and auto. Go ahead and finish up here and meet me there. In this lecture, we're going to zoom in on concepts and the auto keyword. We have already seen that we can do something like this. Use the auto keywords with our functions and let the compiler generate our function template behind the scenes, and this worked pretty well. We could use this syntax to put constraints on our auto keywords, and we saw that the compiler could actually enforce this and throw a compiler error if our concept here is violated. What I haven't shown you is that you can even enforce concepts on variables that you declare. You can do something like this. Set up a variable, say auto x, and call the variable x, and enforce for the variable to be an integral type. I don't really think you have much use for this, because once you call the function and assign a value to a variable, you already have an idea of what is going to come out of the function. But if you have a use case for something like this, please go ahead and use this. It is going to enforce your concepts. You can even use concepts like this. Set up a variable and assign a literal to the variable name using the auto keyword here. But I personally find this useless because you are putting in the value yourself. Why do you want to put a protection if you know that you are putting in a double literal? Then the variable should be of double type. I find this a little bit useless, but it is supported in C++. If you have a use case for this, please go ahead and use this. Now that you know
if you have a use case, I don't know why you would use it, but you might as well use it if you find it's necessary.
Working folder, the current
Roger that, man.
Concepts and auto. We're going to grab our template files and we're going to put them in place. And we're going to open this up in Visual Studio Code. Let's do that pretty quick. We're going to have our folder open. We're going to open the main CPP file, close the left pane and clean things up a little bit. And we're going to include our concepts library. And we're going to put in our function, which is going to be using the auto keywords to really make the syntax nice and cool. But we're going to be constraining our auto parameters here to use integral types. If we call this function with something that is not an integer or an integral type really, we're going to get a compiler error. So if we go down here, for example, and say add and say 10.9 and 0.1, we're going to get a compiler error because 10.9 and 0.1 are double literals, and we only support integral types in this function here.
Right.
So let's build and show you the error, but you must know this by now because we have done this like a gazillion times.
Yep, I agree. We have done this a gazillion times.
And it's going to say required for the satisfaction of integral. So the concept is failing here. We're going to get a compiler error. But if we change this, for example, to 10 and 5, put in whatever you want, which is an integer, this is going to work. We're going to build with GCC. You see, the build is good. So you can use auto with concepts like this. We have seen this syntax already a couple of times in this chapter. What we haven't seen is that, for example, you can set up a variable in main and call this x, y not, and say this variable should satisfy the concept and specify the concept you want. For example, let's say std integral. And if you do something like this, let's see what we get from this. We're going to build. You see, the build is good because if we add up these guys, we're going to generate an integer instance for this function, and we're going to deduce the return type as int. So the return type is going to be integral, and it's going to be assignable in our variable here. But if we change to floating point, I think we have this concept in place. Yes, we do. But it is going to fail because what we get from this function is going to be an integer, and we can't assign to this because this concept here is saying what you try to assign to this variable here should be a floating point. This is the meaning here. And if we do this, we're going to get the error probably. So we have the error. And
Is it
it's
going to
going
be
to
the exact same
say
error as before?
constraint not satisfied.
Yep.
And it is going to say the
Every single
constraint
time.
remain satisfied, which is floating point here.
That is one thing that I've noticed that we do in these lessons is that like it's like, hey, this thing throws up this error, and then like we see that same error 6, 7, 8, 9, 10 times over the over the course of the lesson, because it's like, hey, look at all these different ways you can pull up the same error.
This is how you can put constraints on your variables even when you are declaring them. So another thing we can try here is to assign a literal to this variable here. Let's put in a 3.9 and see if this actually builds and compiles. Let's build with GCC. You see, the build is good, and the
because now it's not
requirement
violating
is for what we assign to
concept.
this variable here should be a double. And a 3.9 is already a double, so no problem. But if we try and make this a 7, for example, this is going to fail. So let's build again. You see, the concept is going to fail. And this is how you can use these things to constrain your variables. I personally find this a little bit useless, at least in this case here, because I know that I have an integer literal and I am assigning this to a variable. Why do I need the help of concepts to really constrain my variable here? But in the case where you are calling a function, for example, using a 5 and an 8, this can come in handy because it's not easy to keep track of the return type you get from a function. Because the function might have a return expression that has multiple different variables, and it's not easy to keep track of what you get back from a function. And you can use a constraint like this to make sure what you get from the function is what you want. And if it's not what you want, you're going to throw a compiler error because the concept you used is going to fail. I would like to welcome you in this
wait,
chapter.
That was fucking sudden, transferring into chapter 17 like that. That was just out of nowhere. But anyway, I think we have a generally good, a pretty good understanding of concepts now. I don't know. I mean, I'm curious to see how much use we get out of this out of the concept of concepts. All right, I'm gonna go ahead and just comment the rest of this stuff out. Honestly, this whole fucking thing could just be here. Just do. There we go. None of it works anymore. Boom. Save that. All right. So the one that we were gonna do, we were gonna do a quiz as well. It was just the very first one, but it has been a minute since we've looked at any of this stuff. But let me, real quick, before I pull that up, let's open this thing. Well, this is just looking at our current progress. So we're on chapter 17, classes. And our timestamp for that is 20 hours, 15 minutes. 42 seconds. Wow. We've made a lot of progress. Look how fucking many different things there are on this goddamn notepad. Which, like, I know that functionally we have the there's also the stuff down here. I mean, it has the time code. But like with this one, I'm going to have to split this one at least in half. But it's looks like it's 3 hours long. Gee, a little bit less than 3 hours. But still. All right, let me pull up the quiz that we wanted to do. This one. Quiz time. Let's do it like this. Boom. Boom. Look at that. No scuff whatsoever. That looked professional almost. All right. So, we're here. So this one was just this was the 1.1, right? 1.x, chapter 1 summary and quiz. Now I was just gonna do the quiz, but I'm not 100% on. This is only like 3 questions, so this should be quick. But I would like to eat dinner at a relatively normal time today. So we're gonna try and get this done quickly. I think. So what is the difference between initialization and assignment? And if my understanding is correct, it's when we take. So if we let me open a notepad real quick. Just to like kind of write and demonstrate what I'm talking about. So when we do like our thing where we do whatever is on my lawn back right on time. I mean, we are gonna basically just do these 3 questions and then and then I'm gonna call it for the day. But it is this quiz is very short, only 3 questions. So the first one is a difference between initialization and assignment. So like the first one is when we do like this, we are assigning the value 3, or we are assigning. It would be probably int first, right? Or assuming this is inside of a body, but like we're assigning here. We're assigning x a value of 3, which is it's something that we can do midway through. If my understanding is that we can do this pretty much any time in the code. We can assign a value, but if my understanding is correct, we could not have something like this to like this doesn't make sense if my understanding is correct. This is like initialization. This is what you start the value with. So like with this, it's like x is a value is a variable with a value of 5, versus here x has been assigned a value of 3. So this doesn't make sense, but doing like this does, because this initializes it with 5, and then this one changes it to this one assigns it a value of 3. So I don't know exactly how I'm supposed to word this this answer, but I hope that what I've kind of said here is close enough. So let's read int x equals 3 is also initialization. Is it? I was kind of under the impression that this was like a different thing. Because isn't it like, because this one says this is copy initialization. Oh, so what is the? Because this is. Oh, there's all these different things. Oh my god. Direct initialization, direct list initialization. Oh no. Yeah. So then I'm not really sure what the difference is. I know that if we do this, we can it changes the value midway through, and I don't know if doing this one, if doing this will change the value after. This shouldn't matter right now too much. I mean, whether it matters is kind of a I don't know if that's all right. Let's see what let me see what the solution says. I want to see what it says. Initialization provides a variable with an initial value at the point of creation. Assignment gives a variable a new value after the variable has already been defined. Oh, I mean okay. So that makes sense. I think this is I this specifically I don't know if this probably doesn't matter. But assignment is the one that comes after. I think I had that concept. I'm pretty much right. I'm curious whether my understanding is that this avoid int x equals 3, x equals 5 is assignment. So if I just did like this would be assignment. Int x equals 5 is initialization. Okay. So this by itself would be assignment. Like here we create the variable. We create an integer called x with a value of 5. Here x is now equal to 3. Direct list initialization is the modern syntax. Yeah, because this is the one that we've been using in all of our stuff. Like pretty much any time that we initialize a variable, this is the one that we use. Here, let me make this. Boom. We're just gonna have this up in the. We're just gonna have it in the corner. Fuck it. If it covers some of the text, that's then so be it. But I think at the very least, I think I had the concept correct, where assignment is something where you change the variable. But seriously, C++ initialization is something I don't understand, and 99% don't either. Just don't worry about it. Fair enough. When does undefined behavior occur? What are the consequences of undefined behavior? Oh god, fuck. So when does undefined behavior occur? I mean, that seems like a very... I'm going to come back to that one. That one seems a little bit harder. Write a program that asks the user to enter a number, then enter a second number. The program should tell the user what the result of adding and subtracting the two numbers is. Oh, well, okay, I have, okay, can you just believe me if I tell you I've already done this one? Did the tutorial not cover undefined behavior? We covered like some things where it's like, hey, if you do this, your program will crash. And I think I don't know if I have it clipped, but I do have a thing where I crashed my whole shit. But that was not undefined behavior. That was just overloading my RAM. But like undefined behavior was like what was it? I I don't think I don't remember what it would have been. I don't remember the phrase undefined behavior. So, what is this? Trying to get the value of an uninitialized variable will result in undefined behavior. Yeah, so it's not the crashes. It shouldn't even compile, right? Trying to get the value of an uninitialized variable. Oh, no. Okay, no. It was junk variables, wasn't it? Or like junk values. Like it doesn't actually give anything. Oh god, I don't remember. Click on the show button for undefined undefined behavior. Let's look at it. Undefined behavior occurs when the programmer does something that is ill-specified by the C++ language. The consequences could be almost anything from crashing to producing a wrong answer to working correctly anyway. Yeah, so I don't think that we covered it with like this. I don't think that it was called this, but we've seen things like this. We did a few different ones. There was like things like I remember there was one where it was like if we had oh god, there was one thing that we did I think on the heap where it's like we hadn't released the memory or something, and then like a pointer now had a junk value in it because like nothing, it didn't really make sense. You did heap stuff, yeah. That was a while ago actually. That was what? That was under flow control, I think. No, not flow control. What am I saying? What the fuck was it? Dynamic memory allocation. Yeah, we did it during pointers. I think this was the first one that used the heap. And it was like we used we had to put in fuck, what was the what was the thing? It was like something, and then we initialized our variable, and then like we had to make sure to release it specifically afterwards, and then any pointers that we had pointing at stuff in the heap needed to be changed to null pointer afterwards. It was very, it was kind of confusing. I didn't quite understand what the heap was. Like I understand it in concept, but like I don't really know why I would choose to do that over just continuing to use the stack. It seemed very it seemed more complicated than it was worth, at least at the time. But yeah, we've done some things with undefined behavior, but basically it's when you fuck up. Heap is your RAM. Oh yeah, we definitely used the heap then. I crashed my whole shit. I don't know which. I think I actually have. I don't have it clipped, but I do have. I think I have the link to it. It's basically during my. Yeah, when I started when we were when we were messing with pointers, of course. But it was something where like I think the point was that it was supposed to be. Uh, um, I forget exactly. Oh, it's been so many things that I've learned in this. Not all undefined behavior is bad though. I mean, yeah, so what it says here is like it could be anything from crashing to producing the wrong answer or just working correctly. You know, it could just work. You know, we could be Todd Howard in this bitch. You know, like it's just I don't know what the problem was, man. It'll just work. It works. Yeah, but then this one, okay. So this, I actually have something for this that demonstrates similar things, but it already works. It was like the one that I put in was basically like hey, this is your cat's age in human years, or some shit, and it was like fucking, it's like how old is your cat, and then it was like okay, it's like 7 years old, and then I just multiply it. Can you do it again? Let's see if you remember. Oh fuck me. Hold on, let me open up Visual Studio Code real quick. File, close folder. No. Stop. Open folder. And we'll go to, I think I have a new one. Alright, all right. And we're going to go to this one, and it's going to be this. And I'm going to get rid of this thing. Notepad. Notepad, go away. Let's see if I remember. Okay, so this one, I think this one's going to be... need to get rid of this. Program should tell the user what the result of adding and subtracting the two numbers is. So this one was... Damn, you were learning about the spaceship operator? No. We were not learning about the spaceship operator. So that's like the frickin' the default like template code that we have, that it has like our JSONs and stuff. I was struggling so much because my C++ was out of date when I went and was doing all this shit, and it was a huge pain in the ass. I couldn't figure out why it didn't work because the spaceship operator didn't exist on the one that I was trying to get my shit configured for. Okay, so here we have okay. Then enter a second number. Okay. So oh my god, do I even remember? So we want to create std cout. We're gonna have it say enter a number, and we'll have it end line, I guess. And then from here, I think we want to do cin. Oh fuck, I don't remember. Hold on, let me look at the thing real quick. So STDCN and operator. So that makes it seem like STDCN, call it, I don't know, int number 1. No. Yeah, it's gonna be this. See, if you binge watch a tutorial, chances are you will end up not learning not that much. I mean, it's not so much binge watching though. It's like what, an hour each day where I'm trying to follow along. Is that what binging is? I was always under the impression it was like, oh yeah, I watched like 8 hours in a single day. Trying to make sure what was it? CN. I don't remember. Kinda, yeah, because you're not really writing much stuff. It didn't go to waste. You know the concepts. I mean, it's not. That's true. But part of the challenge with some of this stuff is like coming up with the solutions yourself and recalling all of the shit that you know. You can click show solution if you want. I mean, I'm like, I'm I kind of want to here. I want to look at the one that I had from before. I had it freaking. I want to say it was in. No, don't save. It'll be fine. Let me see this. It was something. I had all this shit written. This is our addition. It's our multiplication. Did I do this one? First param, second param. This one is multiply. This was done. This is just the very first one. I don't remember which folder or which file I had it. I do remember. Here it is. So we have our string, which just is like this. Please tell me your cat name. STDCN cat name. And then, so we had to initialize 2 different things, and then we could get them we could assign them from the CN. So what I can do then, if I go all the way back. Actually, no, we'll just do it from here. Fuck it. I'll do this. This isn't too. This part is very. What is it? So here we go. What is that? We're initializing 2 integers. We'll call it int number 1 and int number 2. We'll have our stdc out. Let's just play. Please enter number 1. And then here we'll get our stdcin. And this is our number 1. And then stdc out. Please enter number 2. Then we have our stdcin number 2. Oh, what was wrong? Wrong way. Number 2. And then we can do our. This one's multiply, but we'll have to create a function by the looks of it. We'll do int add numbers, int a, int b, return a plus b. And then we will do this thing. It was just going to be your result is, and then we'll do add numbers, number 1, number 2. And then like this should do what we wanted it to, right? Enter an integer. Oh. We get enter an integer. The output program should match the following. So enter another integer. Do we need to do one for subtracting as well? Sub numbers, return a minus b. And then here we go. So we want the output to match that, so we'll do std cout number 1 plus number 2 equals. And then we can do this one as add numbers, number 1, number 2. I'm almost certainly making this more complicated than it needs to be. Is there a reason this one? Oh. We can take this same thing, except it's sub numbers. And then we do minus here. And this should work. This seems like a lot of text, I think, but it should work. We have enter an integer, enter another integer. We have 2 inputs that get called number 1 and number 2. And then here we created 2 functions that will do the outputs. So then we go file, or not file, terminal, run task, and this should build. Build finished successfully. So then let's, no, not run. What am I looking for? I'm looking for new terminal. Enter an integer, and so this one will do 6. Enter another integer, 4. Yeah, I didn't end line, did I? Yep, I forgot to end line. Alright, let's build again. Terminal, run task. Boom, boom, boom. 6, 4, and there we have it. It's not exact. I don't know if I don't know how strict it wants me to be with that. So, but this is done. This has done everything that this one wanted me to do. So let's look at the solution. So we have our include IO stream. That's way at the top here. We have our main. And we have enter an integer. And we called it number 1 instead of x, but functionally we initialized both of ours beforehand. Before doing this thing. So I don't know if that would be considered incorrect, but it might be. And then here we have our in, so where we enter one. This one, same deal, but we use number 2 instead of y, and we didn't initialize in this way. This probably would have been better to do instead of just doing it empty like this. Like if we had done them like this. Actually, yeah, no, we definitely want int still. But this probably would have been more correct, cleaner to do. And I don't know if it matters where we put it in here. But we could move our numbers into here to be like so. And then here we had number 1 instead of x plus number 2, and then we used an equal signs instead of is, and then we used a function when we didn't actually need to. We didn't need to create a function for this. But so I don't know if that would be less points or more. I feel I liked making the functions. So I don't know. How'd I do? Is it cheating because I had to go back and look at this? Probably. Probably, to be honest. But yeah. They grow up so fast. Fuck do you mean, man? This is stuff from chapter 1. This is the chapter 1 summary. What do you mean they grow up so fast? Dickhead. But yeah, I am gonna go get some food. It is dinner time for me. So I'm gonna hop off. I'm gonna close. Boom, 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 boom. And all right. So I had a good time hanging out with you guys today. I hope you had a good time hanging out with me. It's been almost 3 hours. There is a slight chance. There's a slight chance I don't stream tomorrow. At least not the C++ stuff. We'll see. I am a little bit I'm a little bit sleep deprived, and I'm struggling to get that under control. But hopefully insomnia does not fuck me all the way up again. But we'll see. We'll see. Like I said, it's only a chance, and we're starting frickin' classes with the next one. So hopefully that's not as confusing, not as difficult as I'm kind of expecting it to be at this point. But yeah, later guys, I hope you have a good one. We will be back eventually. I'll probably stream later tonight. Gaming stuff, if that's of any interest. Later, bye.